All right, so in this next section, we're going to look at absolute value equations and how to solve them. So it's really not all that different from solving regular equations. There are going to be a couple of extra steps that are involved though. Now, when you're looking at an absolute value equation, the first thing that you want to do is you want to isolate this absolute value. So it's possible that you could have things being multiplied against it, you could have things being divided from it, you could also have addition or subtraction. In this case, we have a 2 being added to our absolute value. So we want to move that 2 over before we start working with the absolute value itself. So we're going to subtract 2, and we're going to be left with the absolute value of x is equal to 7. Okay? Now, you might think that this is your answer, but you're not done yet. Remember that if we have a number inside of that absolute value, it could be both positive and negative and still gave us the same answer. So we've got a little bit of work we still have left to do. What we're going to do is once we have this absolute value isolated, we're going to take it and we're going to break it into 2 separate equations. But before I do that, I want to tell you one thing that you definitely need to know. Any absolute value, remember that absolute value is always going to be positive. So anytime that you have an absolute value that's been isolated, and that's the key, it's been isolated. If you have an isolated absolute value that is equal to a negative number, then you have no solutions. Now in this case, we have an absolute value that's equal to a positive number, so we need to carry on with the next step and go ahead and break this into 2 separate equations. And so what we're going to break this down to is x equals 7, and then also x equals negative 7. So what you want to do is take whatever is inside that absolute value, drop the absolute value signs, and then set it to whatever is equal to 1 positive and 1 negative. Now if we had anything else inside of the absolute values with that x, we'd have to work it down from there, but you can see we don't. So all we're going to do is we have a solution of 7 and negative 7. To check this, just go ahead and put each one back in. So put 7 in for the absolute value of x. The absolute value of x is 7, plus 2 is 9, and 9 equals 9. Plug negative 7 in for x. The absolute value of negative 7 is 7, plus 2 is 9, and we know that 9 is equal to 9. So both of these are solutions to our problem. Okay, now you can see in problem number 3, we've got a little bit more complicated of a setup. This time we're given 3 times the absolute value of 2z plus 9 plus 12 is equal to 10. But we're going to follow all the same rules that we've already been over. What we need to do is isolate that absolute value first. Now, in order to isolate that absolute value, we follow the same rules that we would use to isolate a variable. And that's we're going to use the opposite of the order of operations. So normally with order of operations, again, we would go parentheses, exponents, multiplication, division, and then addition, subtraction. With this, we're going to start with the addition and subtraction, then do the multiplication, division, work on any exponents, and then work on any parentheses that we have. So we're going to subtract 12 from both sides. When we subtract 12 from both sides, you can see that we're going to be left with 3 times 2z plus 9, or the absolute value of 2z plus 9, is equal to negative 2. We're then going to divide out the 3 in order to isolate this absolute value. And when we do that, we've isolated the absolute value, and we have 2z plus, the absolute value of 2z plus 9 is equal to negative 2/3. Now at this point, you should recognize that you have an isolated absolute value, and it's being set equal to a negative number. Once you see that, just stop, because you know that this cannot be equal to this. An absolute value cannot be equal to a negative number. So the answer is no solutions. Now before we move on, I do want you to see how we would solve one of these more complicated or longer problems. So this is an extra problem. This is not found in the book. We've got 5 times the absolute value of x minus 2, minus 5 is equal to 10. So again, follow your rules and go opposite the order of operations. So add 5 to both sides. And once we do that, we're now going to have 5 times the absolute value of x minus 2 is equal to 15. Divide out the 5 in order to isolate the absolute value, and now you're going to be left with the absolute value of x minus 2 is equal to 3. At this point, since the absolute value is isolated, you want to then break this down into 2 separate equations. So we're going to drop the absolute value. We're going to go x minus 2 is equal to 3. Then we're going to go x minus 2 is equal to negative 3. So remember, when we do this, we're going to break it into 2 separate equations, but one of them is going to be set equal to the positive solution, and the other is going to be set equal to the negative solution. Now, all we do with this, add 2 to both sides. So x is equal to 5. Add 2 over here, and x is equal to negative 1. This right here is allowed because this is x, not the absolute value of x. Before we move on, we want to check this. So take your 5 back up here and work this through with order of operations. So 5 minus 2 is 3. The absolute value of 3 is 3. 3 times 5 is 15. Minus this 5 is 10. So this answer checks out. Try the negative 1. Negative 1 minus 2 is negative 3. The absolute value of negative 3 is 3. Times 5 is 15. Minus 5 is 10. And 10 does equal 10. So the answer negative 1 also checks out. So you have 2 solutions on this one. You do always want to check to make sure that both of your solutions are correct. It's very rare that we're going to have a simple absolute value problem where one of them is correct and the other is what we call extraneous. But go ahead and check them anyways, just to make sure that you're getting complete points on your homework, your quizzes, and your tests. Okay, so here in problem number 4, we're going to check out how absolute values work whenever we're dealing with inequality signs rather than equal signs. We're going to do the same steps, but we're just going to flip something when we get to the right time. Now here you can see that we already have an isolated absolute value. So that should tell you that we don't have any steps to go or to do in order to be able to get to that isolated absolute value. So we're going to go ahead and split this into 2 separate inequalities now. One is going to be 8n is greater than or equal to 24. So basically you're going to keep the same inequality, you're just going to be dropping the absolute value signs. For the second one, we're going to go 8n, but we're going to flip this sign now. And instead of greater than or equal to, we're going to go less than or equal to, and we're going to make this a negative. So this is going to be 8n is less than or equal to negative 24. Next step is to go ahead and divide out the 8, and you can see that we get n is greater than or equal to 3. Over here, again, divide out the 8, and you're going to get n is less than or equal to negative 3. So to test this out, don't plug in 3 and negative 3. Instead, plug in a number that's greater than 3 or a number that's less than negative 3. So a number that's greater than 3 would be 4. So try it out. 8 times 4 is 32. The absolute value of 32 is 32. And 32 is greater than or equal to 24. So that checks out. On this one, we need a number that's less than negative 3. Now remember, don't get confused on this. Negative 4 is less than negative 3. Even though it seems like it's bigger, negative 4 is less than negative 3. So plug in negative 4. 8 times negative 4 is negative 32. The absolute value of negative 32 is 32. And 32 is greater than or equal to 24. So that checks out as well.